Then we have an interesting topic, which in most cases is one of the fundamental topics when it comes to a GIS, but it's a complex kind of topic, not complex in use, but complex in understanding. But if mathematics was your friend back in the day, then this is a topic that you're able to understand quite easily. So when we talk of spatial reference systems, we are talking of the system that we refer or that we use to allocate the coordinates that we are using. So we have two broad classes, and we'll be able to see the geographic reference system and what we call the projected reference system. To put it simply, think of geographic reference system for data or for areas that are bigger. It could be a continent level, country level, could be world level. And then think of projected systems as systems that are used for specific areas. It could be a county within a country, it could be a state within a country, or it could be a zone. So these two systems play a vital role because they are related, of course, but in terms of usage, you need to understand which system you are using, because every location on this world has its own coordinates, and that is based on a specific reference system. So you need to understand that before you work on data, understand which reference system you are dealing with, because this will affect how you work. For example, measuring distances, measuring angles will be affected depending on the reference system that you use. So we have a very simplistic approach here, or example, and as you can see, one example. For example, the map that is on the left, you are seeing that is covering the polygon that or the area that we've drawn much further. It seems quite bigger than the one on the right. And this is because, or this can happen to you. So when you're dealing with the data from one specific area and you're using different systems, it could get you different results. So this is why I'm insisting in GIS, before you even start working with the data, know that you need to understand which reference system you are dealing with. This will go a long way in helping your work as a GIS analyst. So simply put, we have the globe, and we've been hearing or been using these terms quite often. We have latitudes and longitudes. You might have heard that the longitudes, the latitude and longitude, if you have one point in a certain town or in a certain area, there's no other area on the world or on the globe that has the same coordinates. What is leading to that? So we go back to mathematics, where we drew the Cartesian plane, and we know the line that is running from the north to south, that is basically the Greenwich meridian, and we have the one running from the west to the east, which is basically our equator. So when working with the data, we need to know which location we are dealing with. For example, someone who is in South Africa will not deal with the systems the same as someone who is in Egypt, for example. Or someone who is in America will not deal with the same systems as someone who is in China. These are different zones or different areas, and as you can see, they are demarcated by these two major lines that pass through the globe, and they are definitive elements when it comes to this industry. So as I've mentioned, we have the prime meridian, we have the equator. We need to understand, because on the equator we have the north and south, and on the meridian we have the east and the west. So of course, we know a sphere has 360 degrees. We need to understand, for example, if you're dealing with areas, or we are dealing with angles, you need to understand the aspect of degrees. How many degrees to the right? How many degrees to the left? What is the distance from Nairobi to Mombasa? What's the distance from Nairobi to Cairo, for example? These are areas that you need to get or need to understand. So when it comes to, for example, even in the world time system, it's based on these two elements. We have the prime meridian. Someone say that it's 4 p.m. GMT, or it's 4 p.m. EAT, meaning East African time. Someone will use Pacific time. Another person will use other type of or other system of time. So all these are referenced because or are referenced due to the occurrences of the meridian and the equator that we have on this globe. So when it comes to the different aspects of the two lines, we look at the axis that we are dealing with. And whenever someone talks of latitude and longitude, we usually think of a location on the globe. But what determines that? Of course, we know the line running from the north to south, which is basically the meridian, has the definition of, for example, if you're moving to the east, it's positive. So that means, for example, if you're going to the east from the meridian, you are gaining, like the degrees are recorded in positive figures. When you go to the west, it's on negative figures. So whenever someone gives you a latitude and longitude that has a positive figure, you will of course ideally automatically know where that falls within the globe, and vice versa is also true. So you need to project the globe. For example, you're talking of a sphere or a surface. When it's projected to a flat surface, which you usually refer to 2D, we are able to give or to understand it in a more perspective in terms of outline and in terms of the way things are laid out. So if you look at what we are calling, for example, the projected system, one of the examples is basically what we call the UTM. And the Universal Travis Marketer, you are able to look at the world in terms of zones. So again, as I mentioned, the zones are not defined because we've already projected from the sphere to now a flat surface. We define the globe, or we define the world in 60 zones. So these 60 zones, we know that a sphere has 360 degrees. So when you divide it into 60 zones, it essentially means that every zone represents 6 degrees. So these 6 degrees have differences in time, differences in distance, and all that. So whenever you're referring to a place, for example, if it's Nairobi, I'm saying, or I'm telling someone that it's on 36 north or 36 south or 37 north, 37 south, I'm referring to a specific zone. So each zone, as you can see from the representation, each location, regardless of where you are, has a specific zone information that you can use. And in most cases, where you're located, in most countries, you'll find maybe there are 2 zones, so 2 or more zones. So just be able to understand where or which system to use. Then we have another kind of representation of the same concept. This will be able to understand, as I mentioned, I'll share this presentation so you can look further and do some more research on this. But there are different representations of these systems that we're talking about. So you'll find a system that has cylindrical representation. We have another one that has conical representation, and we have the spherical representation. Remember, all these are different, and each, as the example I gave before for Idaho, you will find that depending on the projection that you are dealing with, will have different elements that you compromise. It could be area, it could be distances, it could be angles. Okay, so we give an example. Here we are looking at a map of Somalia, and we can see Somalia here, part of it, the lower side of it falling on zone 38 north, and this, the reference that we are dealing with here is specific because, as you can see, the 2 vertical lines are representing the zone. So whenever someone is in Somalia and someone talks about 38 north, you're able to know which zones or which areas that are touched by that zone. And whenever you're carrying out, for example, your survey works, you always set your devices to that system and you can collect your data easily. So I'll not go through, want to basically come to these illustrations. As I mentioned, the other system where we look at the 0, 0, center 0, 0, which is basically representing where the equator and the meridian meet. From there, as we move to the east, you gain like there are those degrees, and in terms of representations, you have the negative and the positive notation. So meaning that if it's positive, you're moving from the meridian to the east, and if it's negated, it's from the meridian to the west. And that's the same case for when you're going to the north and you're going to the south. To the south, you negate; to the north, it's